So here we can have a, like a, for instance, here you can see, okay, wait, here you can see we have a layers. So we have a troposphere, which is nearmost, stratosphere, mesosphere, thermosphere, exosphere. And from mesosphere throughout thermosphere and yes, in the exosphere itself, we have a one different layer that is being called as ionosphere. That is being called as ionosphere. Okay. So this layered wise arrangement is based on what? Air density and its behavior, which is there. The air which is in the troposphere, the air which is in the stratosphere, yes, the air which is there in the thermosphere, all of these will have a different density. So to mark them, we have a one zone, and that zone is given name accordingly: troposphere, stratosphere, and mesosphere, and so on. All right, let us see that how or what composition is there with respect to our atmosphere. So composition of atmosphere, majoritarily if you see, so our atmosphere is dominated with the nitrogen. Almost 78% of nitrogen is there, and this nitrogen is very much required for the plant growth. Nitrogen fixation, you might have heard. So there will not be a nitrogen fixation if the nitrogen is not there in atmosphere. That's why it is required, and yes, it is required in terms of more or less animal functions. So we have a 78% of nitrogen composition in our atmosphere. 21% is oxygen, which is required for all living individuals for their respiration purposes. So 21% is oxygen. Argon, then we have a carbon dioxide, then we can have a so many other gases. Okay, so all of these gases are comprised, or let's say they have their composition role with respect to the 1%. So argon, then we can have a so many man-made gases as well. Okay, CO2 is also there, chlorine could also be there likewise. So first of all, if you see gases, so we have a nitrogen, 78%. It is inert and it dilutes oxygen, and it will going to control the combustion. It is vital for living or these organic compounds, amino acids which are there in our body. They are being formed, or like in their formation, nitrogen play a phenomenal role, not only in human but even in plants and in animals. Nitrogen play a significant role, so that's why it is very much required. Oxygen, the composition of oxygen or share is 21%. As I told you, it supports respiration. Combustion is also being supported by oxygen. Formation of oxide is also there. When the oxygen reacts with any other chemical, there will be oxidation, and as the result of that, there will be a formation of oxides. Then we could have a argon, we could have a carbon dioxide, we could have a ozone, and we could have a neon, helium, hydrogen, methane, and these xenon type of gases which are under this 1%. So carbon dioxide is very much required because it absorbs heat, regulate climate. It is increasing nowadays because of the fossil fuel burning. You'll get to know that how this CO2 will going to absorb heat. Okay, you'll get to know, don't worry. Ozone, you will have a deep dive on ozone, and in these upcoming session you will get to know. So there is a concentration, and that will going to absorb the ultraviolet radiation. If ozone would not have been there, possibly there might not have been survival on our earth surface, because the high energy insolation which is there, incoming solar radiation, sunlight which is there, that might have penetrated in our skin, and we might have suffered through cancer instances if this ozone layer might not have been there. Neon is there, helium is there. They also these gases are also required for some sort of we can say heating and cooling of our atmosphere. These gases are also required with respect to the climatic circulation, heat redistribution, as far as they are concerned. So they also have a role in that way as well. Water vapor, if you see, so with respect to the liquid states we are talking, so water vapor is almost 0 to 5% in atmosphere. However, with respect to the composition, mostly gases are there. So the source of water vapor is what? Evaporation. Okay, water vapor will decrease. Remember, water vapor will decrease with latitudes and altitude. Water vapor, the concentration of water vapor will be decrease. Concentration of water vapor will decrease with latitude and altitude. So at poles, if you see, if you see, so here you will have a less water vapor. Why? Because you have a less insolation, you have a less incoming solar radiation. That's why you will have a less water vapor. Here in the equator or in the tropical region, you will see more water vapor. It's because of what? It's because of the insolation, which is more. Here, with respect to the altitude, majority of the water vapor which is here, that water vapor will be concentrated near to the surface. Okay, mostly below the 5 kilometer water vapor which is there. So whenever we have a evaporation, as a result of evaporation, the water which is there will be formation of cloud. How? You'll get to know. Then that process will be called as what? Condensation. Now as a result of condensation, cloud formation will be there. The state of water vapor, the state of gaseous, sorry, the gaseous state of water will be changed in liquid. So this process is called as what? Condensation. So water vapor will be transformed in terms of water droplets, and these droplets, when they will fall on the earth's surface, that will be termed as precipitation. And the water which is falling on the earth's surface, that will going to collect in the water bodies. Then again, if there is an insolation, as a result of this, there will be evaporation. So this cycle will go on continuously. And yes, this cycle is being known as what? This cycle is being known as hydrological cycle. Okay, it is the water vapor and its presence in atmosphere which led to the formation of cloud, rain, fog will be there, dew will be there, frost will be there, hail and snow could also be there when we have a water vapor which is present in atmosphere. And yes, with respect to the temperature and the behavior of water vapor with respect to the temperature will play a significant role, will play a significant aspect as far as the climate or as far as these activities are concerned, in terms of whether there will be formation of cloud, how and when there can be a rainfall, how and when there could be a fog, dew, frost, hail and similar things. Yes, water vapor, there is a significant aspect that this water vapor will going to absorb long wave radiation. Now what is long wave radiation? See, our earth is there, and our earth used to heated from sun. From sun we have a high energy waves, and when these high energy waves are arriving on surface will going to absorb that particular energy, and that's how surface will become what? Warm. Now this will be called as what? Insolation. This is incoming solar radiation, so it is being termed as what? Insolation. Now, as per the law of thermodynamics, if there are two bodies and if these two bodies are in thermal inequilibrium, they will going to exchange heat with respect to their mediums. So here we have a medium of heat exchange, radiation. There are three mediums: convection, conduction, radiation. So here we have a radiation through which the heat exchange is taking place between these two bodies. Clear? Now, this could be the scenario during the day. But when we have a night, during the night, what could be the scenario? That now the earth which will going to radiate the heat in order to get cooler, in order to release the extra energy which has been absorbed in case of insolation. So the energy which is absorbed, the extra energy which is absorbed by the earth's surface, that will going to radiate off, that will going to release back in our space, in our atmosphere. So when earth is releasing its energy, that will be termed as what? Long wave, because it will have a less energy. Okay, it will have what? Less energy. This is what the long wave, this is what the short wave. So with respect to the basics of waves, when we have a like a more amplitude, here we have a amplitude, and yes we have a wavelength. So here we have an amplitude, and yes we also have a wavelength which is narrow actually, so it will have a high energy. as compared to this, it will have a less energy because its wavelength is broader. So less energy is there. Here we have a less energy. Here we have a more energy. So long wave radiation, which is emanating, which is coming from the Earth's surface, Earth is releasing in order to get cooler. I mean, in order to get the temperature of Earth cool, for example. So there will be a releasing of long wave radiation, and this long wave radiation will be trapped by water vapor. This long wave radiation will be trapped by water vapor. Okay, and yes, it will lead to the atmospheric warming. If this energy will be absorbed by water vapor will lead to the releasing of this energy in the atmosphere itself. That's how atmosphere will become warm. So the cooling and warming of atmosphere is always being determined by the various layers of air, including water vapor. Now you will get to know in upcoming sessions that why there is so much noise with respect to this global warming, and why there is so much noise with respect to this climate change specifically, and what are the processes associated with them. Moving ahead.